Are you ready,
so.
Durmas?
Yes.
Okay. So with me again is Durmas Cesur with DC Water. He's going to be talking about our event management system and all of the great things that they're doing at DC Water, and I think you guys are going to find it really fascinating. So Durmas, without further ado, if you want to go ahead and take us away.
Okay, thank you. Again, this is Durmas Cesur. I'm working with the DC Water for over 4 years right now, and I'm working as an asset management systems manager, managing the both GIS, enterprise GIS, Azure-based GIS, and Maximo IBM-based Maximo systems in a nutshell, and then data integrations, associated projects, programs, you name it. And one of these projects is emergency event management system. Actually, it had what's called emergency at the beginning of the tag or the name, but we dropped it because of the connotations or annotations. There are some limitations as to what you could use emergency-wise. There is a limitations, and NWS kind of a limits use of emergency event or emergency alerts. All this stuff a little bit kind of a to be watching out. In any case, emergency event management system is is the system that we developed in order to address the emergencies, especially flooding, water outages, things like that in the organization. And first of all, I'd like to go over who we are, what we do, before we get into further details. I think most of you already know DC Water. DC, we all know, nation's capital. We are located in the what's called nation's capital, and then providing the what's called water and sewer services and stormwater services to the what's called DC, District of Columbia, residential and commercial customers and industrial customers in a nutshell. About 700K population, and then about 300,000 users in a nutshell, to my knowledge. And then overall, like in the DC metro area, we have 2.2 million customers actually. Like what it means essentially, we have wholesalers for the what's called area water organization, water sewer organizations. For example, Fairfax Water or the Washington Suburban Sanitary Commission Water. All these guys kind of all their sewer treatment done by DC Water, just to let you know, at our what's called DC water treatment facility located at 5000 Overlook Avenue, which is about here, right here somewhere. And because of that, we have some wholesale customers, and then we have some, residential or individual personal customers. That's what I'm trying to say more of. And we are treating the wastewater for about 1.6 million people. Of course, given that, this is the nation's capital, we have every single day tons of visitors, you name it, from all across the nation. So it's actually more than this number, just to be clear with you, because of the what's called temporary resident visitors, all this stuff in a nutshell. And then we are pumping 95 million gallons of water to our customers every day, and then collecting and treating 300,000 gallons of wastewater every day. And then we have around 10,000 public hydrants for fire suppression or fire services, fire-related services. And emergency event management system, that's what I'm going to be talking about, is the system that our executives kind of asked us to develop to provide the situational awareness, emergency awareness as to what's going on, as to the DC water services. And then whether we are providing the service in a timely and efficient manner, whether there are service issues like flooding, clogging, you name it, water outages, things like that happening throughout the district area or our responsibility or jurisdiction area. That's the reason why we embarked on what's called development of the emergency event management system, or in a short name, event management system. It's composed of dashboards, sorry, to provide the emergency event information for the water quality, sewer, and other issues, flooding and other issues in a nutshell, based on what's called certain incident types, select number of work orders, select number of incidents in a nutshell. And we have incident tracking system built on top of it. Every day, our customer center is essentially gets the call from the customers indicating that they have water outage, indicating that there is a pipe burst, there is some kind of a backwater in their basement, things like that essentially. So we enter these incidents through our incident tracking system. And then we have water track and flood track to show the what's called water related events or flooding related events. or the incidents and work orders associated with them that we create or our command center creates in order to handle the what's called these issues. We have water ops and sewer crew dashboards in a nutshell to show the what's called what these crews, water ops crews or the sewer crews are doing on the ground, where they are located right now in real time through what's called essentially geotab and similar vehicle tracking systems and things like that essentially be incorporated into these dashboards. And then at the same time, we are incorporating the real-time sensor data from the field, like pressure data, temperature data, you name it, all gazillions of what's called pressure sensors or other sensors do exist out in the field. And then we are collecting this data and then plugging into the what's called these dashboards to provide the real-time situational awareness across the board for all our users, especially executives, to understand, what's going on, where things are, what we are doing, how we are doing in a nutshell. And we incorporate with the third-party applications. Especially in this regard, we are incorporating with the DC Waters alert system, like providing the what's called feedback from this alert system, providing the weather data from third party and from the National Weather Service, providing the what's called some other like staging data, all this stuff from the USGS, things like that, essentially, as well as part of the third party tools or data feeds integrations are concerned. And we are providing the what's called at the same time alerts to the what's called essentially on events. If there's something happening at certain location, we got, let's say, more than 10 calls at certain location. We are kind of treating this as a what's called event. Like there is a number, like certain thresholds. Like when a certain threshold within certain area passed, we are considering this as a serious event. There is something happening. We need to find out, and then we need to resolve. We need to address this issue in a nutshell. So that's the kind of a definition of the event. There are business rules at the background that runs, and then at the same time informs the users, like sends an email, sends the what's called SMS messages, things like that, to let them know there are something going on over here. You need to kind of dispatch the crews to get this issue addressed. And this is the incident tracking system. As you can see on the left-hand side, we do see the what's called essentially incidents being entered by our customer command center, customer service. And then we have the live stream as well, like data feeds, essentially providing the what's called additional context or information for our customer service people. And then we have the summary information on top of the map, on the top of the geospatial platform, which is based on the ESRI, as I already expressed, ESRI services and maps in a nutshell, providing the summary information. We have on the right-hand side, we have the capability to integrate with our asset management system to create the work orders based on the incidents that we face, and then link them with the associated incidents to provide what's called some kind of a daily summary as to what incidents being handled by what work order, which work orders. And then we have capability to show the real-time vehicle information, vehicle tracking system being incorporated, or the system data being incorporated through the APIs, GeoTab API. And then we could show the what's called all this information on the map as to where the crews are located, what they are doing right now, through the incident tracking and management tool. And then we have at the background, this is a background service more than anything else, just to be clear with you, messaging management system built upon to show what we are kind of handling, what kind of message is being shipped out to the what's called users, like their emails or the what's called SMS, their phones, things like that, essentially. What kind of issues being kind of communicated, summary information provided for the messaging management system as well at the background that runs, incorporated with the what's called incident tracking system. And the second dashboard we developed is the what's called flood track system, which is kind of showing the what's called flooding related events. In June 2022, as far as I recall, there was a flooding event. For example, we were showing the what's called essentially what's going on across the what's called district area. And we are showing the what's called flow rates, pumping station situations, how they are acting or reacting, put it that way. And then we are following up on the incidents, like whether there is anything reported as to the catch basin flooding or clogging are concerned after the flooding that generally happens. And then work orders associated with what's called these events being kind of shown on the left-hand side, right here. And then on the right-hand side, we are showing the what's called essentially real-time data feeds from the pumping stations as to how they are operating, and then stormwater pumping stations as well being shown over here. And then on the map, we are showing the what's called essentially districts or subdivisions. I may put it that way. And then showing the summaries as well as to the work orders, as to the what's called wards, and then incidents and work orders and vehicles in these wards being shown on the what's called essentially associated windows or the associated tables or charts. I may put it that way. And then at the same time, as you could see over here, we are providing the real-time weather information as well, on top of the what's called other weather information from other sources. This is a third party, like private company, essentially information, I may put it that way. And this is water track. We are showing the what's called water related incidents on this what's called dashboard with associated summaries, reservoir and tank levels, for example, on the left hand side, and then on the right hand side, pressure, discharge pressure, all this information on the right hand side. And then at the same time, we are showing the what's called essentially live stream incidents being created, all this stuff, and then work order situations, overall, our incidents and work orders are concerned, and then providing the summaries per word, and then providing the associated legend on the what's called water track dashboard. I may put it that way. And then this is the Cesur crew dashboard, like showing the Cesur related events, like, clogging, things like that, essentially. In summary, on the left-hand side again, over here we see the vehicle information, Cesur crew vehicles, essentially, what they are doing, where they are located. And then on the right-hand side, as you kind of click on the what's called any one of these vehicles, it kind of zooms to the map location and shows you where the vehicle is. On the right-hand side, we see the what's called essentially work orders being created. At the same time, we have capabilities to search for the work orders, like specific work orders, that find out what the status with this work order is concerned. And then we have kind of a simplified statuses on the right-hand side, as you could see, like completed, in progress, and field complete status being shown on the dashboard as well in a simplified fashion. And then water ops shows the what's called water-related events or incidents overall. What we have, like overall over here, like as you could see, status of the what's called essential work orders being shown. On the right-hand side, pressure sensor information, like how they are kind of behaving right now, being shown, and then short data summaries on the map together with the map itself. That's what we see. And then we have the map navigation items, as you could see over here, listed too. And then these are the alerts dashboard, again, based on the number of incidents at certain area, 1 kilometer, if I'm not mistaken, kilometer square area. If there are more than 10 incidents, we are going to be like, indicating like alerted. And then if it's more than 20, then we are going to say, so event is happening type of a deal. There are some business rules being incorporated to account for the what's called number of incidents. And based on that, sending the alerts to the what's called end users, especially customer service guys, to let them check into and then dispatch the crews, create the work orders accordingly. And over here at the background, of course, this system kind of works with the admin UI, like configurable. It's a configurable application that works with the admin UI. You could kind of change the parameters, change the location of the widgets, change the location of the panes, things like that. Change the what you want to show, all this stuff through the admin UI. You could modify the things. We could set the what's called refresh times. You could add parameters, delete parameters, update the parameters based on the changes that we do at the background system. Like for example, Maximo or GIS changes, or let's say we want to incorporate new weather feed, or we want to incorporate some other feed, some other data, some other sensor data. We could do it through that UI in a nutshell. It's simply configurable application in a nutshell. That's what it provides us. This admin UI provides us these configuration capabilities that we have available in this responsive design based or responsive design application with the responsive design, I may put it that way. And in 2022, as you could see over here, we had what's called the Essential Smart Water Project of the Year award in Madrid, Spain, just to let you know. It's a global award being given, and then that's what we got, because of what's called this emergency event management system with real-time data feeds to provide the situational awareness across the board, across the organization, targeting especially our executives, and then at the same time targeting the public and our users like crews, all these guys, essentially to find out where these things stand, and then to provide the transparency across the organization as to the emergency events are concerned and how we are reacting or how we are addressing these events are concerned. And with that, I'd like to stop here. Actually, I have a video, but I don't think that I'm going to be able to fit it in. But I'd like to share this video with you as well so that you see how the system is kind of being operated or how the system being run in real time with the video feed. But let me do the following. Maybe in the short period of time, I may show you the system. I'm going to stop sharing, and then I'm going to share whole screen. Just give me a second. I'm going to say whole screen share. And the system we are talking about right here, applications, emergency event management system. And it's coming up right now. And that's what we are talking about. This is the kind of, again, situational awareness, real-time data feeds application, configurable application in a nutshell. That's what we are talking about. Everything is configurable. You could kind of visualize the information. These are the kind of different dashboards that we provide, and then being updated with the real-time data feeds. And as you could see,
and we're right at 10:15,
and
so I'm gonna move on to the next one. This is really impressive.
Thank you. I appreciate it.
All right, thanks so much. I'm going to go ahead and switch it to Chris as the presenter.
Yep. Hey, thanks, Durmas. That's DC Water always doing such cool things. It's really great that you guys got together with us to share today. And if anybody does have any questions for Durmas, please put them in the chat, and he can start answering those questions for you while we move on to our next presenter. Our next presenter is with RTK, Alpha RTK. His name's Chris Kahn, and a lot of near and dear to our hearts is centimeter accuracy data and high accuracy data with in AEC workflows. So with that, I don't want to waste too much of Chris's time, so I want to turn it right over to him so he can get started talking about Alpha RTK. Go ahead, Chris.
Terrific, thanks. I'll just do a quick sound check to make sure you can hear me okay.
We can hear you and we can see your screen.
Terrific. All right, well, thanks for having me. It's great to be able to follow DC Water. I won't be quite as impressive. I always love seeing their stuff, and I'll definitely be checking out that video. So my name is Chris Kahn. I'm founder of Alpha RTK, which is both a geospatial consulting firm, but it's also a product. It's also a service of RTK, GNSS corrections for portions of the Mid-Atlantic region. So I'm going to actually, let me pop up into presenter mode here, just to get you out of that. And to say a little bit about me, so I really take a geospatial focus rather than a surveying focus on RTK. Certainly, people who are surveyors can purchase the RTK service from my company, but largely I have my experience in asset data collection. Just quickly a little bit about Alpha itself as a service. It's right now all of New Jersey, New York City, Philadelphia area, expanding fairly rapidly. Pretty unique approach, really working with universities. So 4 university systems right now: Rutgers, Westchester University, Warren Community College, and Shippensburg. 2 additional schools that'll be very well-known names are coming on board in the next month, but I can't name them yet because they're not exactly signed just yet. A whole bunch of base stations are in the hopper. So expanding pretty rapidly. I just want to mention it's 1/3 of the cost of other services out there, and a true 4 constellation correction service. Just a quick note about expansion. Those light blue, if you go to the website, you'll see the coverage map, ArcGIS coverage map, and those light blue circles are the bases that will be coming over the summer. But I wanted to spend most of the time today really talking about how do you use RTK. So those days of GIS when I started 22 years ago as a macro tool That's still very much true, but it also now has the ability to take all of that analysis, all of those workflows, and bring them down to the centimeter or 1-inch accuracy. And I'll talk a little bit about how one of my clients is using that in practice. So I'm just going to pop out of this and bring it into a story map for the rest. Let me know if you are still able to see the story map screen.
We are.
Great, just a quick check. So I'm going to talk a little bit about, for the remainder of the time, about how RTK, UAS, so drones, web and mobile and offline mobile GIS are being used in an architectural engineering construction project. This is a really cool project. I got introduced into this because I do a lot of work with golf irrigation installers on really high-end golf courses where you don't want to disturb the turf. Everything has to be exactly where it's supposed to be. So RTK is really useful in that. They had a really unique problem in this island. It's down in the West Indies. Can't mention what the island name is. I'll allow you to guess if you want to. But it was largely uninhabited. And you got about 300-400, $10 million homes going here with, really gorgeous golf courses. And there was no infrastructure for communication. So there's no cellular, no internet. So how do you provide high accuracy GPS and interactive maps to earthworks crews, basically changing an entire environment across 100 square miles? So it was a pretty unique problem, and they brought me in because basically the irrigation installer said, "Hey, I know this company that could probably help." So that was a cool opportunity. I threw a quote in here from my last visit, which is in March, and talking with other construction managers who had worked, in Africa, Indonesia, the deserts in the Middle East, and he said, "Chris, this is the moon." He used more colorful language than that, but he said it's the hardest thing ever to work on, just because of how hard the logistics are in this place. So the challenge here, and what I was asked to bring in and solve, is like they have huge amounts of clearing and grading and surveying and field adjustments. All of these crews across this place that had to coordinate with land development, architects, and engineering. And for those of you who work in a construction environment, you know that as building in real time, it's really important that there's always field adjustments, particularly in an environment like this. Like, things are going to change, and they need to relay that information back to architects and engineers who change the design. So there's a lot of friction and a lot of money loss in that exchange of information. So they wanted to solve that to really make it all real time. They, of course, use standard surveying on the project. However, that's really slow. And most of the things they're doing don't actually legally need surveying. So they brought me in to sort of solve some of these problems. And I threw the requirements up here where, we needed offline capable, sub-inch accurate. We needed a bidirectional communication between field, office, and people 1,000 miles away. Everything interactive maps, online, offline. Interestingly, they needed cut fill calculations because they're moving millions and millions and millions of cubic yards of sand around. So real-time cut fill calculations were pretty important. And definitely very important was Autodesk interoperability. So I'll play a quick 30-second video here that shows sort of the end result. That's a ground control point you're just looking at on the screen. Let me apologize for the low resolution in the video, but I promise when you're really using it, it's high resolution. But what you're looking at is offline use of ArcGIS field maps, and some of the lots here that have been fully constructed and others that are under construction. All of what you're looking at is as-built data coming from, or design data rather, coming from the architects and engineers, and then the field folks can see it, and they're using high accuracy GPS, so everything they're building is perfectly aligned to about a centimeter with what they're able to see themselves in the environment while they're working. So I sort of skipped ahead to the end product, like what the solution was. I'll talk about 3 different things. So the mapping and interoperability, I'm going to skip around here, the GNSS RTK, and the UAS workflow. So taking them one at a time. For the mapping and interoperability, this is sort of the easy part. Wanted to introduce them. They had no idea what GIS was basically on this project. Introduce them to ArcGIS Pro, ArcGIS Online, originally Collector. This was started in 2019. Now they've migrated to ArcGIS Field Maps. Autodesk connector for ArcGIS for those civil users, and then Esri GIS or AutoCAD for those that are only using AutoCAD, like landscape architects. The GNSS solution is a little bit harder. So no internet, offline maps on ArcGIS field maps and ArcGIS collector before that was fine. But how do you get that high accuracy? Well, you got to use UHF for that. So I paired EOS Arrow receivers, EOS Arrow Gold receivers in the field with a serial port on the side into a UHF radio. And on the base station that I built, I installed a 50-foot high whip antenna that broadcasts that UHF signal. Actually works a lot better than an N-trip connection. Not better, but it's instant. It's faster. You don't have to log in, I guess is what I'm trying to say. And then for the UAS workflow solution, so they always have this high accuracy, up-to-date imagery. I trained them on how to use DJI Phantom 4 Pros to produce repeatable maps that they're always flying over the same area to provide these updates. On the ground, I had to install ground control points because I needed to make sure that these are always accurate, and I had the surveyors survey these. So you see a picture of one right there where it's basically a 2x2 square block of cement with a rebar in the middle. Super easy to make these, and then painted on the top would be one of those familiar checkerboard patterns. Here's just a photo. It's kind of a long photo, so I'll scroll through, but that's one of the UHF repeater antennas. So that's me standing up right after I built it. What these do is this is 7 miles away from where the base station is. So that UHF signal is line of sight. So as I get further and further away from the base station, I need to repeat that signal to cover the whole 100 square miles of the project. Taking a quick peek at the time, 5 minutes left. So I'm gonna zip through some of these examples now and show some of the fun stuff. A few maps I'm going to go through. So this is a big project area, and you really can get a sense of how remote this is. The base station is about 7 miles away from this project site, and this project site is where the golf course and about 300 homes are going to go. So if I scroll through, you can see the progress being made there. They actually started, let me just full screen it. They started the project down here, and there's a base station here. The very first thing they built was the irrigation lakes that power the irrigation for it. And then as I move up, you can see the golf course, the grass being planted. And then up here is completely new, and eventually it'll continue onward. The base station itself is right over here, about 7 miles away. And this is another part of the project. You can see a couple of years ago from this drone imagery, not much had been done yet. But if I scroll through, you can kind of get a sense of how quickly they're moving. Look at some of the finished homes there. Really cool about this project too, they are building a privately owned international airport with service to Miami. So that was the first for me to be on an international airport runway before it opens and flying drone surveying. It's pretty neat. In this interactive map here, you can see that there's that airport that they're building, and down here is the main project site. You see all the CAD data for the site in there, and I'll just use some bookmarks so they keep an eye on the time. Zip through and show you some examples of how they are using design data and as-built data in real time. So those black contour lines are coming from the drone. Those are hyper accurate elevation surfaces. And then the brown lines are design. I don't have to match design exactly, but it's really helpful to earthworks when they're pushing all that sand around to in real time know what elevations they're at. I should say near real time. Zipping over to back of house, this is an example of where they're building a tremendous amount of structures. They can do so rapidly because if you think about it, they're just looking at basically a desert, cleared sand, and they're able to locate where they are standing and build the pilings that they need to build for these facilities. Same thing with the golf course. I mean, golf courses are built with laser scanners on the greens, at least. They're able to match that accuracy with the GPS and do things more rapidly. And those blue dots are actually the infrastructure mapping using ArcGIS solutions for the data model of the irrigation. So I kind of adopted the water data model a little bit for an irrigation system. Note to Esri, please build the data model for golf course irrigation systems. It'll be helpful. And then finally, surveying, right? The surveyors are doing traditional surveying, but everything they do is perfectly aligning up. And you can just see how hyper accurate those foundation wall design drawings are with the UAS imagery of what's actually being built. Skipping to the end there, I have one more to show. So even the non-GIS people who aren't building things, the finance folks have a lot of value in this. Like I said before, they're moving so much fill around, it's really expensive. So they have these grades they need to hit of 9 feet and 11 feet on buildable lots that they're selling to private owners. And if I zoom in on this dashboard, what's helpful about ArcGIS from like a management perspective is, every one of these drone flights, you're able to total up, how much money they need to spend this month on fill based on the lots that they're planning on bringing to grade. Of course, you can always do this in engineering and in Autodesk Civil, but it's very expensive and it's very slow. So since they're already flying the drones, we're able to calculate this for them and display it in a way that's sort of easy to use. So if I zoom on some of the completed lots, you can see, hey, there's no more fill required because they've brought this to grade. Big goose egg there. But then some of the other ones that they're working on right now, you can see, how much is left. So that's kind of neat. And I'm almost right at time, so I'll just kind of finish up with showing a photo of what the finished product looks like, which is pretty beautiful. It's really fun to walk around there. That's all I have. And if there's any questions, I'll stick around to answer questions in the chat. Thank you.
I was going to ask, just to remind everybody, put your questions in the chat because we have a pretty tight window. So I'm going to now switch us over to Michael Boyd.
Yeah, how cool was that? That's awesome. Alpha RTK. If anybody has any questions for Chris, please feel free to put them in the chat. That's really cool stuff. Thanks for sharing that. With me now.
Present now.
With me now is Michael Boyd with Novotx, and I personally speaking, and Larson Design Group have worked with Novotx a great deal, and know that they have a really cool product, and I'm sure Michael has a lot to say about it. So don't want to take up too much of his time, so I'll turn it over to Michael Boyd with Novotx, highlighting their Elements Asset Management solutions.
Thanks, Matt. I'm working on sharing my screen. I never used WebEx before, and now it's wanting me to change my system permissions. So give me a second here. Glad to be here with you. Novotx is we are a software company based out of Utah. We do asset management software. So like I heard CityWorks and Cartograph mentioned before, they are, I would say, competitors of ours. Just to kind of let you know that there's other options out there besides those two. It looks like I have to close WebEx and then come back in order for the work. So hopefully this will only take 20 seconds and I'll be right back.
No problem.
So as Michael's getting ready to jump back on, I'll just remind you guys that we have one more presentation coming up after this, and then we're going to have a quick 10-minute break, and then we'll be right back up for some voting pools and our board positions that are really coming up, and a little bit of socializing before we move on to the next slate of presentations. So hopefully everybody sticks around and takes part in all those things, and we still will probably wrap up here around 1 o'clock.
Michael,
you
we
hear me?
can. Yep, we can see your screen, Michael.
All right, great. Okay, you can hear me, you can see my screen, and you probably see me on camera. So let's get going. Talking about today, leveraging workflows. Now, a lot of this was covered in Esri's presentation. So I'm going to kind of, because I have a short amount of time, I'm going to just kind of skip the slides that I've prepared and just jump into some actual like live demonstration of kind of seeing what I'm talking about in action. So let me jump over here. You should be seeing what looks like a software page. It's our dashboard for Elements XS. So the name of our company is Novotx. Just think of the word robotics, but the software that we make and sell is called Elements XS, complete enterprise asset management system. So we have several entry points into the work. So this is where we can look at a map as we're looking at work and tying work to assets and different things like that. So I'm going to use, this is an actual customer of ours, Springville, Utah, and we're looking at their GIS data here. And so what I want to do is kind of show you kind of what the more manual process is for doing work, tying it to an asset. And then I want to show you kind of how we can speed that up using some workflow processes and involving the map to be able to be more efficient. So as an example, somebody out in the field could select on an asset such as this and see some details about this particular hydrant. And I'm going to show some other examples of other public works type examples, but we're going to start off here with a hydrant. I can see a history on this particular hydrant when it was last repaired or flushed, other work that's been done on this particular asset. So the manual process of creating the work would just be coming in here, selecting the different type of tasks that I do for this particular asset. It's only going to show me stuff related to work that's being done on this particular asset. So in this example, I'm going to do a flow test. So this is where somebody would come in and do the work. Now, take in mind, I'm on a desktop, right? If I was out in the field, it would look something more like this. But so you guys can see a little better what's happening, I'm going to just use my desktop version here. Someone probably might mark this as being in progress. They have some details that they need to fill out, taking some information in. In this case, I'm going to mark this hydrant as needing repair, and I'll show you why here in a little bit. Now, this is going beyond like workforce. So Esri's workforce, we are actually tracking material consumption. So somebody can come in here and add a pipe. How much pipe did we use on this particular job? Who is there? Maybe I'm putting in my crew or myself here. I've been at this job for an hour. This is my rate. This is equipment that I'm using today. But we can also kind of speed this up by using what are called inventory kits. So let's say every time I do this particular job, it's this set of materials, it's this labor, it's this equipment. I'm just going to populate that in here, nice and quick and easy. It makes it easier for the guys out in the field. And then I can come in here and I can edit quantities and things like that. So now we have here a roll-up cost. $531. I can snap a picture if I want to. This just opens up the camera on my device. And then I can save and close it. And then I'm kind of just done with this job. And then I can move on to the next one. So let me bring this job back up here. I want to show you something. Here is the flow test that I just did. I just performed. Because I marked this particular asset as needing repair, it automatically scheduled a follow-up to be able to go out and repair it. So that's kind of a more basic workflow. Whenever I'm collecting this data, what triggers are going to happen as a result of the data that's collected. Is there a follow-up action? Are we coming back 6 months later to check on a leak? Those types of workflows. And so that is more kind of the basic level. Now let me show you how I can speed some of this stuff up. So let's say I have here up on my map a workflow that starts where I'm going to select multiple assets. Okay. So I've selected 3 hydrants here on my map. I'm going to say it was this people here. It was this piece of equipment, maybe some additional information, and I'm going to add that in here as being done. So what that allowed me to do from an end user perspective is I didn't have to open up a work order and then complete all those different sets of information. I was able to do it straight from the map. I was able to tie it to multiple assets, and I was able to do it much quicker. So it made it a little bit simpler for somebody out in the field. Now, another thing I want to show you here is, see, we have these links that can also trigger workflows as well. So in this case, I want to report that this particular hydrant is leaking. So with one click, I'm going to say that this hydrant needs work to be done. And then in the background, here's the repair work that was scheduled out. It automatically assigned it to certain people to go out and do that job, or maybe a supervisor to schedule it out. Here's the materials needed to complete the job. Here's the labor typically needed to complete this task as well. And so that made it quick and easy with one click of the button to be able to complete that particular job. All right, so I'm going to switch gears here, show you a street example. Let me bring up here my streets layer. Here we go. And then I've got some various workflows here that are triggered here from the map. So for example, I want to do this particular work on street. I'm going to select multiple assets here, these 3 streets. And what I like about this is it allows me to do more than one service order task or work order on multiple assets. Okay, so in this case, I'm doing a crack seal, I'm sweeping and cleaning. These are the employees that are there. This is the equipment. This is how long it took. And then I'm going to create that work and be done with it. And so what's neat about that is I just completed 6 work orders, service orders on 3 different assets. So if somebody had to manually fill that out, it might take like 10 minutes, but because I'm using the map and workflow technology, I can speed up that work. All right, let me switch gears again here. I want to show you a sewer example. Let me bring up my sanitary sewer system. And here on this map, I've highlighted the sewer lines that need to be jetted. In red, it shows that the last sewer jetting date, let me get a sewer line here. Okay, I can see the details on this particular asset. The last time it was jetted was in 2018, and as a result, my map is rendering it red. So that tells me that I need to be able to do work on this particular asset. So I'm gonna select my workflow to do some routine jetting. Okay, I'm gonna select this particular line that I'm working on, and I have a user definable form, very simple as to the work that I need to record when I do this particular task. And what I'm doing here is I'm identifying that it has some issues going on. So I'm going to complete that work. And then if I refresh my map, this has now gone from red to green. And I've updated the GIS to the last jet date of today. And as a result, it does not need any jet cleaning. But here's also a neat thing as a result of this workflow. Because I identify it as having heavy amounts of roots, grease, and grit, it automatically scheduled a mechanical rotting truck to come behind me and clean that out. So which was great, because you have guys going out doing one particular thing, maybe inspections or work, and then the work that they are recording, the software is making decisions based upon that work. And so at the end of the day, charts and graphs, results, what information are we collecting here? I'm going to just turn on, this is a heat map that's showing where do I have high concentration of work being done, or where am I spending high amounts of money on, in this case it's inventory, but maybe labor costs. And I can see how that graph is changing. So we have some information that we're collecting here. But also, let's say I want to run a report from the map. What are my assets with the highest business risk? If I have $1 today, where do I need to put that money? And so this is reports telling me where that is and what years I need to budget to be able to accomplish that. So I sped through that, but this is just kind of showing you some ways that we can take workflows, involve the map, and be able to create some neat things. And like that question was asked before about the workflow manager and being used in CityWorks and Cartograph, we are heavily investing in that right now to be able to take workflow manager and use it within Elements XS. So any questions? Well, I guess you just do them in the chat, and then I can maybe follow up with the questions, because I think I'm out of time.
Awesome. Well, that was actually really good. I think asset management is one of those things that touches on, multiple industries across everything, higher ed, water, wastewater, local government. So thanks for taking the time and going over everything with us. If you do have any questions for Michael, feel free to drop them in the chat, and he'll address those as we work through our next presentation, which is UMBC, and they're going to be talking to us today about higher ed, talking about master's program and how they're tweaking it and making it more applicable to today's GIS. So with that said, I'm going to turn this over to Ron Wilson and Dillon Mahmoudi.
Hi, everybody. I guess one of the things that, what goes in all this good work is an education behind it to prepare students to go out into the workforce and do these things. My name's Ron Wilson. Dillon Mahmoudi will not be here today, so I'm just going to be presenting. We have designed our master's program, the GIS program and master's and certificate program at UMBC has been around since about 2009. But over time, we realized that things have changed in society. The market has a certain level of saturation in some of the areas that just required us to say, look, we need to sort of revamp and move in a different direction, particularly with new thoughts behind a lot of this. So I'm going to present that today. So Dillon Mahmoudi is the program director, and I'm the assistant graduate program director for the program. I'm also an instructor in the program. I've been with the program since that 2009. I moved into this position because Dillon and I got together, and it was like we had very similar ideas about where we wanted to go with the program. So that's who's running it. And now I'm going to go over a little bit of the foundation of the program. So what we decided was to go make this a very distinctive program in a number of ways. We wanted to focus on applying what's called critical GIS, which is a lot of applying detailed thought into every aspect of the geographic information system concept, from not just in technical terms, but impact on society and the limitations of it, and what work can be done and what can't be done, and very kind of looking at it from all angles. So we're do this to improve the lives of people and their livelihoods, to put forth more social engagement, and look at environmental conditions. So our program is designed to encompass the scientific aspects of human activity and policy making to facilitate place-based analysis for decision making. So the idea is to really just it can cover human and environmental conditions for the most part is what we're looking to focus this program. So critical GIS is that core principle of it. And so in order to be critical and apply this to the betterment of human society and environmental conditions, we have just fused these ideas together where what we do is we provide a lot of geographic theory and concepts as our foundation. A lot of programs, you know, the technical stuff, things about geography, but we spend time dealing with teaching students like the main four families of geographic theory of spatial dependence, spatial interaction, spatial organization. To name just a couple, so that they understand where all of this is rooted in. It's how it relates to other disciplines, because as we know, we use GIS in more than just necessarily pure geography type applications. So we're also looking to provide computing depth and breadth and versatility. We're looking to educate students that are platform independent, but still have the ability to use the main software programs out there, because they're, you know, there's a reason why they're the main software programs out there, as well as, you know, needing them for employability. But we also want them to have skills in R and Python and QGIS and Quattro, and being able to use these products in ways with GitHub and various other sensor technologies that give them the opportunity to sort of build what a real system is. But we also bring the science and technology studies to this program, where we want to assess the impact of what students do in creating solutions for place-based activities, so they understand how to think about, okay, if I propose this particular solution, what is going to be the impact on society, the environment, if I decide to do this, or I do that, or I try this solution, so that they take responsibility and assess what their work will do. I've worked in a number of agencies in the past for the federal government, where I was particularly doing work that was to be implemented on the ground. And through that time, I started realizing that when I make decisions or I put forth analyses, that this directly impacts people's lives. Most of that was within working with police departments, putting crime analysis systems in place, or HUD, evaluating housing choice voucher programs. And as like realized that my work hits the ground and it impacts people. But we also emphasize communication. We want eloquence in our students, the abilities to be very, very, very distinctive in terms of communicating, not only written, orally, but graphically. So we have a particular focus on graphical excellence that we have throughout the program. But because we're master's program and division of professional studies, it's an emphasis that they want solid communication skills, so that when students can present writing samples and write for publications and get through the editorial process and be accepted, because it's competitive, to whether it be popular literature or academic literature, it's competitive to get that work out there. And if we're going to make an impact with geography and GIS, we need to be able to communicate it very clearly and succinctly. So the objectives of our program are boiled down to about 8. We want students to recognize the connection between the classes and how it relates to critical GIS. A lot of times, you know, in the past, one of the sort of shortfalls in our original program is that the courses weren't necessarily all tied completely together. But now we've designed it so that our classes mesh together. There's a little bit of overlap. And we emphasize a number of things to say, this is how this relates to this other class. And we'll do co-projects with other classes, so students have a connection, like, oh, I see how this works in this class. We have students build and organize a portfolio across the program so that they have a finished product at the end. They'll learn how to use Quattro and GitHub to present their work in a way that can give them the skills in using those tools, but also a way of putting their own work forward to a potential employer, or just trying to sell what their products, or what they're thinking about in terms of who they are and the kind of work that they do. As I mentioned before, we develop technical skills with a variety of GIS software and programming languages, with a particular focus on R and Python. Those of you who have used both know that one's kind of better than in one area than another. We want to make sure that students have that breadth and depth, not only for just employability, but as I mentioned, there's strengths and weaknesses to each R and Python that can serve as a student. And particularly if you can't solve one task in one language, you can go to the other. Same way with the GIS, whether it be ArcGIS, QGIS, or any other GISs are out there, or trying to use the programming to develop your own GIS. One of the main pillars, though, and the objectives is to develop methodological problem-solving skills. We found over the years that when people do projects, there's not really sort of a methodological plan and sort of thinking things through from start to finish, from developing a concept and an abstract idea, starting to put pen to paper and whatever the solution it is in, design all the way through. So for example, my students, when I put them through geoprocessing, I actually take them down paths where they're actually geoprocessing data, and they get pretty far in, only to find out, because they didn't think about this and plan this out, that they have to undo a lot of work that they've done to undo that and get down the path that they need to be able to combine data in the way that they do, or that they need to figure out an alternative way around if that is not possible. So we do tell them, like, if you plan this out, this is how you can achieve this and save yourself some work and some steps and understand that impact down the line. As I mentioned, we do cover social and environmental subjects to focus on modern issues. But this leads to the core thing of the critical GIS, is to critically and ethically assess the work to recognize the impact on people or environment. I personally have been in a number of instances where people just kind of took the attitude, it's like, well, we got to come up with a solution. And there's like, this is the solution, and they go about their day and they don't really think about the impact on people. But it does happen. I mean, I've seen it. And so, but we want them to think the larger impact of society, not sort of direct all the time, but sort of long term of what happens if you make these decisions and map them out and think about that total impact. But in the last one is to sort of balance objectivity with subjectivity. We're always taught in science that, to be objective as possible, but being rigorously objective sometimes does not get your solutions out there. And sometimes they're a little too rigorous and don't really match the reality of being out there. So where you bring that subjectivity into place, the passion of why you do what you do, or why you're going to apply these skills, and the impact that you want to have on society. Those things kind of drive finding ideas to solutions, and particularly because that's the area that you want to apply it to. But subjectivity needs to be in check so that biased solutions aren't put out there to favor one particular way of thinking or a personal bias or anything like that. So we think that from the work and research that's out there, that the two can be balanced with each other. It's kind of like Thomas Kuhn's, like the essential tension between advancing, practice and research. And so we're trying to bring that to that so that students can assess that, bring that passion and that subjectivity to it, but be moderated. So classes are a little bit about the program now. Classes are at the Catonsville campus, and they convene primarily in person. We have found that student engagement over virtual, from research and our own experiences, is like, we want people in the classroom. We want people to develop interpersonal skills and just be there to help and hands-on. So we have a certificate program that you can lead into the master's program if you don't want to do it. There's 6 total courses required, includes project management and leadership. If you go on to the master's program, it's a total of 30 credits, 6 required, with 4 electives, and again, includes a project management with a capstone. As I mentioned, there's a GitHub portfolio as a final product. We are working with real clients, because part of what we're trying to do is connect people with Baltimore and metropolitan DC region to solve solutions give our students experiences, but help the industry and society and the environment around us. I'm going to skip this one to save some time, but we're trying to develop superior communication skills, where we have students writing analytical projects and learning graphical excellence and stuff. Those of you, Hadley Wickham and Edward Tufte, we try to bring those kinds of things to the table. So a little bit about the curriculum, just so you get an idea of what we're thinking. So These are the 6 core courses that for the certificate of MPS, where it starts out with maps or launching spatial databases and processing geographic data, sort of our introductory courses, where Just Map sort of introduces that graphical excellence and the ethical aspects. It's critical GIS. But we have the technical there with launching spatial databases. We need students to be able to technically stand up geographic information systems and not just use them. By the way, we're looking for an instructor for that course and a couple others I'll go over in a bit. Processing geographic data, this gets mostly familiar with the ArcGIS's geoprocessing tools. A lot of times geoprocessing is put forth as like union merge and all these things, but no, there's a lot of tools in there for geoprocessing we put students through so that they understand that toolbox is wide open for a lot of solutions in ways that they had never thought. So they come out really strong power users. Web GIS and statistics for geography. So they get a round level of technical, visual, programming, and statistical round in the core courses. If we go on to the elective courses, the 12 that we follow up with, these are the ones that we have here. Again, it is a balance of technical. We get remote sensing and satellite imagery in there, as well as some more advanced technical and advanced statistical, as well as some practical courses such as the digital cartography and public crowdsourced data as a way of giving them a breadth of skills where these courses all go in depth and they overlap with each other. We also do a series of seminars and colloquia where we invite industry practitioners and researchers in to come in and give the lectures to the students so that they get an idea of what else is going on out there, not just what we're encountering in the class. So we're bringing people in from the local area and even across the nation and the world to say this is the kinds of things that we're doing elsewhere, so that it's not just the micro area of the Washington, D.C., Baltimore area. We often will have students try to publish things in practical journals. We've co-authored with a number of students to get that experience of getting something written as a written product and out there. And like I said, this is not exactly an academic journal, but it's more one of that it's practice from HUD that we're in. So yes, as I saw that's a comment, we do have we need for the public crowdsourced data, I think digital cartography and particularly spatial regression and advanced statistics. That's one I like to do it, but I just don't have the capacity. So I want to find somebody now. Anyway, for example, so we're not just doing like, this typical things in the classes. So for example, in the statistics for geographers, we not only teach the students the mechanics of the statistics. Here's what the Moran's eye does, and here's what the Geddes Ord does, and go over the formulas and show what they do. We actually put students through critical assessments where we have them use those techniques. So for example, there's a section of this class that does cluster technique evaluation. So the students get familiar with what each one of the clusters techniques do. And we say, all right, you're going to put these into a table and we're going to use these sets of statistics to derive a measurement. It's basically a sensitivity analysis and say, here's which one performed best, here's which one didn't, and the range in between, and be able to tell in a report why those results were the way they are. So they assess each of the techniques and what they're strong in, how the geography and the way that it's measured of effect, so that they understand when they go into the field, which one do I want to use under which measurement conditions and the data that I have. Same way with the geoprocessing, we have them do a lot of things that are typically not encountered here, where we have them, there's 2 ways to do that, where we have people put in a number of things that require them to do very, very detailed geometric modification between layers, but also attribute.
Thank you, Ron. I think we're out of time.
Okay, that's fine. I forgot to start my stopwatch. So the rest of the analytical products, if you want to get to me, contact more Ron Wilson and Dillon Mahmoudi and even the operations admin team. But there you go. The rest of it, there's the topics that we got. If you want we'll have the presentation, but I'll stop now.